All right, so we're talking about interest formulas. We're talking about making money, which is always important. That's what I'm doing right now. So let's talk about these notes. This is all it. We just have to go through the notes. Make sure you have a calculator with you right now because I want you to try these out on your own to make sure you know the correct sequence of how to hit the button so you can get the correct answer. All right, so when you put money in the account, all right, that money is called the principal. All right, not principal, but principal. Now, that's what P stands for, is principal in this equation, okay? Now, E is its own number, all right? And hopefully you already watched that video on E. R stands for the rate, and T represents time in years. Now, the other thing with rate is that's going to be it's going to be in a percent, so you need to put that into a decimal. Okay, so when you put the money in the account, back up here, when you put money in the account, the more frequently the money is compounded, the more quickly the amount in the account increases. So we're talking about making money, not losing money, all right? Now, if it's continuously compounded interest here, that means it's compounded all the time. So this is the continuously compounded interest formula. We'll talk about another formula here in a second. But it uses E right here. Okay? So let's say I had $1,000 and it was getting compounded continuously. It would be at a rate of, let's say, 5%. 5%, that means the rate would be 0.05. Don't forget, if you're going from percent to decimal, you take the decimal and you move it to the right or to the left twice. And that's where I got this from, okay? And then if it's getting compounded for 20 years, let's say the entire time I was in high school, all right, 20 years, that will be 20 right there. I was kidding. I didn't take 20 years in high school, but that's all right. So then we'd have to multiply these two together inside the exponent here. Take e to that power, all right, because these are exponents on e, and then multiply that by 1,000, okay? And we'll do some examples of that next. So suppose you invest $1,050. So this is what it's going to look like. That goes there. And it's continuously compounded, so I have E here. It's an interest rate of 5.5. So if I have 5.5%, we take that and we go boop, boop. And so as the rate, that turns into 0.055. That's R right there. And then time, it tells us 5 years. So another 5 right there. Okay, so right now, if you were to plug this into your calculator and you did it correctly, you should end up with approximately, and we're talking money, so there's a dollar sign, $1,382.36. If you're not doing that correctly, then you need to either ask me for help or watch a video on how to plug things into your calculator. I would love to help you, though, so please go on a meet and ask me for help. Now, there's a button on your calculator that's e to the x, okay? There's also a caret button here for exponents. So as long as you find this e button or e to the x, you should be able to take care of this portion right here because it's e caret whatever this is. And I put this inside parentheses still. And then take whatever you get here and then just multiply it by that. That might be the easiest way to do it. Just try it out. If you can't get it right, that's when you need to message me on Google Hangouts. Thanks. Now, let's say on number 8, we invest $400 at an annual interest rate of 7.6. So 7.6, we go whoop, whoop. So this would be e to the 0.076 times, and it says 1.5 years. So we got 1.5 in there. It's a 5, not a 6. So now I would take this times that, take e to whatever that is, and then whatever that number is, multiply it by 400. Either way, you should end up with approximately $448.30, which means if we put $400 into a decent account with this rate, and we only waited a year and a half, okay, just a year and a half, we would have made $48.30 without doing any work. We're just leaving the money in the bank to get it compounded. That's what that means. Okay, now we're at a different formula here. It's not being compounded continuously. There are several different ways it can be compounded. We're talking it could be compounded semi-annually, which means it's compounded twice a year. If it's compounded quarterly, how many quarters are in a dollar? Good job. 4 times a year. If it's compounded monthly, then it's compounded 12 times a year. If it's compounded weekly, then it's compounded 52 times a year. Yeah. And if it's compounded daily, then it's compounded 365 times. So that's, let's talk about what these letters mean. This is the amount in the account. All right. This would be the principal. That's a number 1. Hello. R still stands for rate in decimal. T still stands for time. But the only difference here is this N and this N. And N stands for the number of times is compounded annually. All right, so let's do this example here for number 9. Suppose you invest $2,000. If that's the amount you're investing, that is the principal. And then I have 1 plus, and I have this fraction, and then I have it to the power of this times this. So I'm going to go ahead and erase that. Okay, cancel. Cancel that. Oh, I almost hit the wrong button there. So these two numbers up here are being multiplied. All right, so let's fill this in, change the color. Now, it says at a rate of 4.5%. Now, 4.5, I guess switch that, whoop, whoop. So 0.045 goes there. That's the rate. T, it says 5 years, so that's going to be right there. And then it says compounded quarterly. Quarterly is right up here. 4 times a year, every quarter being compounded. So if 4 goes here, and if 4 goes there. And that's how you plug it in. Now, what should you get out? You should get out some money, but the exact amount that you should get out of your calculator when you plug this in is $2,501.50. Okay? Now, keep in mind, what is 4 times 5? It's 20. So technically on this one, what we have here is 2,000, and I have 1 plus 0.045 over 4 to the 20th power. So it's fine to multiply those. Okay, now what I would do, let's say I have a calculator, all right, and it's just my phone. I'm going to walk you real slowly the sequence and how you plug these in, okay? I would first start here in the middle, or inside the parentheses. Take this divided by that, hit equals. Then take whatever numbers in your calculator, add 1 to it, hit equals. Then I would hit the caret button, or the Y to the X button or something, to the 20th power. Then hit equals. Then whatever that number is, I would multiply that by 2,000. And that should give you this. If it didn't, then you're just doing it wrong. And that's okay. I can help you out. Now, let me get rid of this real quick. Because now we have a similar question here with letter B. It says, if you save another $500 before investing, which means if you start with $2,000 and then you raise another $500 more, that would be $2,500. Then how much will you have in 5 years? So it's basically the same question with a different principle. That's it. So I'm just going to rewrite everything else in here. All right, you got to have all this work. You can't just have numbers written down to get full credit. And then if you plug that into your calculator, you end up with $3,126.88. Okay, so that means if we invested $2,500 instead of just $2,000, after the same amount of time, same interest rate, we would have about $600 or more than $600 more in our account, which is good. Thank you for copying these down. Make sure you have all the work. I appreciate your time.